Welcome back to TAE Certification Training Series. Today we will continue with section 4.3, Test Automation Maintenance. Because time efficiency is the main contributing factor to the success of test automation, it becomes critical to have good practices for maintaining the TAs, including number 1, the deployment procedures and usage of the TAs must be clear and documented. Okay, so let's first have a look at the deployment procedures point. So deployment procedures should be clearly outlined, detailing each step required to install, configure, and make the TAS operational. These steps should be explicit and easy to follow. Next one is usage of TAS, which means providing instructions on how to use the TAS for testing purposes. This includes guidance on running tests, interpreting results, and troubleshooting common issues. Number 2, the third-party dependencies must be documented together with drawbacks and known issues. So when you are developing the TAs, you often rely on third-party software components such as testing libraries, APIs, or frameworks. It's crucial to maintain clear documentation about these dependencies. This documentation may include a list of all third-party tools or libraries integrated into your TAS, specifying their names, versions, and sources. Then explain why each dependency is used and what is its role within the TAS. Also document any limitations, bugs, or issues associated with these third-party components. In addition, also include information about the workarounds or solutions for these known issues. Number 3, the TAS must be modular, so parts of it can be easily replaced. First, let's see what is meant by modular. Modularity involves designing the TAS in a way that it is composed of independent and interchangeable modules or components. Each module has a specific function and can be developed and maintained separately. Number 4, the TAS must run in an environment that is replaceable or with replaceable components. So this practice involves setting up your TAS in such a way that it can operate in various testing environments without major modifications. Environments can include different operating systems, browsers, databases, etc. The TAS should be flexible enough to adapt to these variations. For example, if your TAS is used for testing, let's say, a web application, it should be capable of running on different web browsers like Chrome, Firefox, etc. It should also work on various operating systems such as Windows, Mac, and Linux. So this adaptability allows you to test the application across different user scenarios and environments without rewriting the TAS for each setup. Number 5, the TAS separate test scripts from the TAF itself. So keep your test scripts separate from the core test automation framework. This way, testers can add or modify test scripts without altering the underlying framework. Number 6, the TAS must run isolated from the development environment so that changes to the TAS will not adversely affect the test environment. So separate environments should be used for development and testing. The dev environment is where software is created and modified, while the testing environment is where you run your automated test. Also avoid using the same databases or data sources as the development team. Running the TAS separately from the development environment ensures that changes or issues in the development process does not impact the testing environment. It promotes stability and reliability in your testing process. And the last one is the TAS, together with the environment, test suite, and testware artifacts must be under configuration management. So place the TAS and related artifacts under version control. For example, use a version control system like Git to manage the TAS code, test scripts, and test data. This ensures that changes are tracked and previous versions can be restored if needed. So implementing all these good practices enhances the efficiency, reliability, and flexibility of your test automation efforts while ensuring consistency and reducing the risk of disruptions. There are also considerations for the maintenance of the third-party components and other libraries as follows. So before we start looking into the considerations, we will use an example where we will imagine that the TAS is like a library with books and services. Now let's see how it relates to each consideration. Number one, documenting third-party components. Very often it is the case that the TAS will use third-party components to run the tests. It may also be the case that the TAS depends on third-party libraries, for example, the UI automation libraries. All the third-party component parts of the TAS must be documented and under configuration management. Okay, so think of these components as special books in your library. You have got books from different authors and publishers. You create a catalog that lists each book's title, author, and where it's located on the shelf. This catalog is like documenting your third-party tools, so you know that what you have and where to find them when needed. Number two, plan for modification or fixes. It is necessary to have a plan in case these external components need to be modified or fixed. The person responsible for the TAS maintenance needs to know who to contact or where to submit an issue. So sometimes books get damaged or they need updates. So you should have a plan for that. You know who to contact, maybe a skilled librarian or a repair service. Similarly, you should have a plan for your third-party tools. You should know who to reach out if they need fixing or updating. Number three, documenting license information. There must be documentation regarding the license under which the third-party components are used, so that there is information on whether they can be modified, to what degree, and by whom. So books also have rules. You have a library policy that tells what is allowed. Similarly, for your third-party tools, there are licenses. So you need to check these licenses to know what you are allowed to do with them, like modifying or customizing. Number four, keeping components up to date. For each of the third-party components, it is necessary to get information about updates and new versions. Keeping the third-party components and libraries up to date is a preventive action that pays off the investment in the long term. So just like books can have new editions, your third-party tools also get updates. Imagine your library informs you when a new edition of a book is available. Similarly, you need to keep an eye on updates for your third-party components. These updates can bring improvements, just like getting a new edition of your favorite book. So, in conclusion, managing third-party components and libraries in your TS is essential for its long-term success. By documenting and organizing these components, having a clear plan for modifications, understanding licensing, and staying up to date, you ensure the reliability and efficiency of your TAS. It's an investment that pays off over time, guaranteeing the continued effectiveness of your testing efforts. Considerations for naming standards and other conventions include: number one, readability and maintenance. The idea of naming standards and other conventions has a simple reason. The test suite and the TAS itself has to be easy to read, understand, change, and maintain. This saves time in the maintenance process and also minimizes the risk of introducing regressions or wrong fixes that could otherwise be easily avoided. So think of your TAS as a massive library of test cases and scripts. Naming standards and conventions here are like having clear, well-organized labels on each book in the library. These labels make it easy for your test automation team to find, understand, and work with various test scripts. It's like ensuring that every book in the library has a title, author, and table of contents so readers can quickly grasp the content. This readability and organization saves time in maintaining and debugging test scripts and reduce the risk of introducing errors. Number 2, onboarding new team members. It is easier to introduce new people to the test automation project when standard naming conventions are used. Okay, so imagine your test automation project as a complex jigsaw puzzle. When new team members join, standard naming conventions serve as a guide, providing them with a clear picture of how the puzzle pieces fit together. It's like giving them a map of the puzzle, making it easier to understand and contribute to the project. Number 3, what's covered by naming standards? The naming standards can refer to variables and files, test scenarios, keywords, and keyword parameters. Other conventions refer to prerequisites and post actions for test execution, the content of the test data, the test environment, status of test execution, and execution logs and reports. So in your TAS, various elements require consistent naming such as test case names, variable labels, and report formats. Naming standards ensure that these elements are named uniformly and logically. It's like ensuring that all puzzle pieces are labeled correctly so that assembling the puzzle becomes straightforward. This consistency helps your team maintain a well-structured test automation project. Number 4, agreement and documentation. All the standards and conventions must be agreed upon and documented when starting a test automation project. So just as in a library where there are library rules and policies, your TAS project also need clear guidelines. Standard naming conventions are like the rule book that every member of your test automation team follows. This agreement ensures that everyone is on the same page when it comes to naming test cases, variables, or test files. It's like having a documented agreement that fosters collaboration and consistency. So by implementing these considerations in your TAs, you create an environment where test scripts are easy to work with, new team members can quickly adapt, and everyone follows a consistent and agreed upon approach to test automation. This leads to efficient and error-free testing processes. Now let's have a look at the documentation considerations. Number 1, importance of documentation. The need for good and current documentation for both the test scenarios and the TAS is quite clear, but there are two issues related to this. Someone has to write it and someone has to maintain it. Documentation serves as a crucial resource for understanding how testing is performed and how the TAS operates. It provides a reference for testers and developers to ensure that the system functions as intended. In this point, two challenges are highlighted. The first one is writing documentation. So there is a need for someone to create the documentation, which implies assigning responsibility for this task. And the second one is maintaining documentation. Documentation needs regular updates to reflect changes in the system, test scenarios, or any other relevant information. Number 2, documentation beyond code. While the code of the test tool can be either self-documenting or semi-automatically documented, all the design, components, integrations with third parties, dependencies, and deployment procedures need to be documented by someone. Such documentation provides a comprehensive understanding of the system's architecture and operational requirements, which cannot be inferred solely from the code. Number 3 is integrating documentation in the development process. It is a good practice to introduce the writing of documentation as part of the development process. A task should not be considered as done unless it is documented or the documentation is updated. So by integrating documentation into the development workflow, it ensures that documentation is given due importance and is continuously aligned with the evolving system, preventing it from becoming an afterthought. So in summary, this section highlights the significance of documentation, the challenges of creating and maintaining it, the need for comprehensive documentation beyond just code, and the best practice of integrating documentation within the development process to ensure its completeness and accuracy. Training material considerations include: number 1, using documentation for training material. If the documentation for the TAS is well written, it can be used as a basis for the training material of the TAS. In other words, clear and comprehensive TAS documentation can be repurposed to create effective training content. This approach can streamline the process of developing training materials, ensuring that the content is consistent with the actual functionality and design of the TAS. Number 2, components of training material. The training material is a combination of functional specifications of the TAS, design and architecture of the TAS, deployment and maintenance of the TAS, usage of the TAS, user manual, practical examples and exercises, and tips and tricks. Okay, let's have a look at all these components separately. So first we have functional specifications of the TAS. This describes what the TAS is supposed to do. Then we have design and architecture of the TAS. This explains how the TAS is structured and organized. Next we have deployment and maintenance of the TAS. This provides instructions on how to set up and keep the TAS running. Next we have usage of the TAS, which is user manual. It guides users on how to interact with and utilize the TAS. Then we have practical examples and exercises. This offers a hands-on experience to reinforce learning. And the last one is tips and tricks, which provides additional insights and shortcuts for efficient TAS usage. These components collectively aim to equip users or trainees with a comprehensive understanding of the TAS, from its functionality to best practices for using and maintaining it. And number 3 is maintenance of training material. The maintenance of the training material consists of initially writing it and then reviewing it periodically. It is done in practice by the team members designated as trainers on the TAS, and it most likely happens towards the end of a life cycle iteration of the SUT at the end of sprints, for instance. Okay, so the maintenance of training material involves 2 main steps. The first one is initially writing it. So this is the creation of training material including all the components mentioned earlier. And the second one is periodic review. So over here, the team members designated as trainers periodically review the training material. So regular review and updating of training material ensure that it remains accurate and up to date, reflecting any changes or improvements made to the TAS. This helps maintain the effectiveness of training resources over time. So in summary, this section discusses how well-written TAS documentation can be repurposed as a foundation for training materials. It also highlights the various components that make up the training material and emphasizes the importance of periodic review and maintenance to keep the training material aligned with the evolving TAS and user needs. With this, we have completed the chapter 4. In the next session, we will do some practice questions. Till then, take care.